Good morning, everyone, and thank you for joining us for the Solar Decathlon Semifinals competition, day 2 for our office building division. My name is Tanushree, and I'm a researcher in the buildings group at NRIL, and I've been assisting as a jury coordinator for the past couple of years, and I also participated when I was in grad school in 2018. I'm joined by Sydney, who will be assisting us as the jury assistant. Each year, we see a lot of creativity, ingenuity, and innovative ideas come through the competition presentations, and we're very excited to kick off today's events. Based on the presentations at the semi-final event, 10 teams will be advancing for the finals. The agenda for today is as follows, and we can go to the next slide. We will be having 4 teams presenting today. Each team starts off with a 2-minute AV check where we will make sure the audio is working correctly, and the speakers can turn on their video. And we'll also make sure that you're able to share your slides correctly. That will be followed by an 8-minute presentation by each team. And you will be given a 2-minute time warning as well as a final time's up warning. So keep your eye out for Sydney's screen. That's where you'll see those warnings pop up. We'll be starting our first presentation at 10:10 Eastern Time. Next slide. Some housekeeping announcements. I request everyone to keep their cell phones on silent to not distract the other teams, and keep themselves on mute if you're not speaking. And all virtual all presenters are requested to turn their video on so that we're able to engage with you more. And the 8-minute presentation is followed by the 5-minute question and answer period. And if you have any technical difficulties, you can reach out in the chat box and we can help you out. Next slide. Next, I'd like to welcome our jurors and introduce them. We have with us Lisa, who has been committed to sustainability throughout her life, from her first eco-city designed at 8 years old to her time in Portland, back to her hometown of Baltimore. She has over 25 years of experience in sustainability and architecture, and likes to describe herself as an urban scientist, studying the interconnected system of people with each other, nature, and cities. Lisa was previously a sustainability director for a large architecture firm and is now the senior director of sustainable practice and knowledge at AIA, the American Institute of Architects. She transitioned to her current role to help architects across the nation improve our built environment and work for climate change and climate action and climate justice. Welcome, Lisa. We also have Amy with us. Amy is the Director of Strategic Initiatives Service at McKinstry, where she looks at development and execution of initiatives needed to achieve holistic outcome-based service and solution for the life of the building. Prior to this, Amy managed the high-impact technology catalyst program with the commercial buildings integration team at US Department of Energy. The catalyst program weighed changing market conditions against technological innovation to map out a cohesive step-by-step market stimulation strategy that enabled DOE to leverage work by others, access key partnerships, and answer critical scientific and market-related questions. Amy graduated with a Bachelor of Science in Architectural Engineering from the University of Colorado Boulder and a JD from the American University Washington College of Law. Welcome, Amy. Before we begin, can I invite the jurors to say a couple of words, and if there's any advice they'd like to give college graduates that are presenting today as they step into their careers and in general with their presentations today before we start.
I'll start. Good morning, everyone, or whatever time zone you're logging into today. I'm happy to be part of the Solar Decathlon this year, and I just want to first congratulate you all for even getting this far and joining the Solar Decathlon competition. It's a great program thinking about buildings on the earth and how they interact with people and nature and our overall climate goals. So I'm really excited to see our projects.
Yeah, same from me. And just to let you all know that this is a unique opportunity for you to really explore innovative new solutions and test out sort of the opportunity that you have as a building professional to do things that you might not be able to do in your career because of other drivers. So I'd encourage creativity and innovation and really looking beyond sort of the standard methods that are used in every building that's been built previously and towards the future of how buildings really could be built and how they can be a solution as opposed to a problem for sustainability and climate and all of those things. So good luck to everybody, and can't wait to hear the rest.
Awesome. Thank you both. So we have a minute or two, and at 10, I'd like to invite IIT Roper to come and do their AV check.
Hello, am I audible?
Yes, we still have 2 minutes to go, at which point we'll start with your AV check, and then you can also share your slides to make sure everything looks good.
Okay, thank you.
All right, we're at time. IIT, would you like to turn on your video? And we can also do a quick AV check for the speakers and share our slides.
Yes, am I audible?
Yes, we can hear you.
Okay.
And we see your slides. Yep.
Yes.
Okay, that looks good. So we'll begin your presentation at 10:12. So you have another 2 minutes. I'll let you know when you can start presenting. Good luck. All right, you're at time. You can start presenting.
Okay. Good morning, everyone. We Team Tejaswi is here today in front of you all to present our project Kartikeya. It is very important for a person to be fit and fine physically as well as mentally. And what's a better option than playing sports? And cricket is one of the major sports played among Indians, and today it's a billion-dollar industry. Our goal was to design an office building for the same, which not only includes architectural and engineering aspect, but also be market-friendly, durable, resilient, produce less environmental impact, consider comfort and occupant experience, etc. For the same, we teamed up with MPCA, Madhya Pradesh Cricket Association. We, team of 6 architects and 5 engineers with our faculty lead, designed Kartikeya. Kartikeya is a project to be built on MPCA cricket ground, Khandra district of Madhya Pradesh, India, as a part of MPCA cricket stadium. Madhya Pradesh has a subtropical climate which lies at Zone 3 as defined by Bureau of Energy Efficiency India and Zone 1A according to US Department of Energy Climate Zone System. The average temperature of the area ranges from 22 to 48 degrees Celsius in summer and 10 to 25 degrees Celsius in winter, with average annual precipitation of 66.2 millimeters. The site is a semi-urban area surrounded with farmland, settlement, and water body in southwest direction. We, as a team, only need to design the office building for the stadium. Our design form development started with creating a form that's blend in with circular cricket ground. Following an open plan design, large open spaces were created in collaboration with workspaces and meeting area. As designing an office within a stadium requires visual interplay, the orientation of spaces were created keeping in mind about the same, thus creating different levels within. Lastly, the planning is modified for better viewer experience. Building is divided into 3 levels, which also includes a mezzanine level. Zoning of the building is done keeping in mind about semi-public, public, and private areas.
We started with sketching out the floor plans that are coherent in geometry with the practice ground and is aligned in the same axis with that of the cricket pitch. This was done in order to ensure efficient functionality of the spaces and ease of occupants. The orientation is kept north-south to make optimum use of daylight and reduce exposure to heat gain simultaneously. A landscaping with pergolas and open seating can be seen as one enters into the stadium complex, enhancing the visitor's experience, and a water body in the southwest direction further cools down the hot breeze. Here we have the floor plans. Starting with the ground floor, the north wall faces the ground, and the south wall is treated with fenestration made of stabilized earth blocks and with the relatively narrow floor plate strategically designed to allow diffuse light to enter into the working spaces. The building functions as a hierarchy of public space, which is a reception at the entrance, a double height spill out area, gym, and a changing room for players towards the right, which is designed to be semi-public. And on the left are the private areas with double height open working stations promoting a co-working concept. A conference with flexible furniture is at the mezzanine floor for the officials, and for players, they have a lounge at the mezzanine level. The seating for VIPs and officials are designed at the first floor level with a green roof terrace at both the ends of the floor plate, which complements the elevation and prevents heat gain through the roof. These are the sectional drawings of the building. The first section is through the staircase and shows the vertical circulation in the building. An appropriate viewing angle from the balconies at the first floor to the cricket ground is also evident from this section. The section below is through the double height space on either side of the building, which shows the functioning of the stack effect, creating cycles of positive and negative pressure of air infiltration.
Here we are looking at details of various construction components. Firstly, there's a flat roof with provisions for drainage and thermal insulation. Vegetation and growing medium are used to create a green roof. The growing medium is placed on top of waterproof membrane so as to protect the underlying roof structure from water damage. For the facade, double skin glazing with pivoted glass windows has been provided. Double skin comprises two glass layers, air flowing through the cavity in between. This space is great for insulation and reduces air conditioning costs. Next, the filler slab. It involves laying a grid of reinforced steel bars on the walls of the building, then hollow clay pots are placed in between the bars, then pouring concrete in the pots to create a solid slab. Both the external and internal walls have insulating material placed in between the wall frame. RCC bands and vertical ties make the structure ductile. The blocks are laid in the form of flat trap bond that creates a cavity or air gap between the walls of the building. This cavity allows for better distribution of load, thus giving better stability to the wall. The material used for the walls is compressed stabilized earth blocks. The embodied carbon and embodied energy are considerably lower in a meter cube as compared to that in fired clay bricks. These blocks are made using locally available soil, help limit deforestation, and at the end of their life get mixed with earth, all of which are sustainable land use practices. This practice of relying on CSEB load bearing construction goes beyond energy savings. It aims to revive the community of workers involved in stabilized earth block molding who have been struggling for livelihood due to the prevalence of RCC construction in India. We believe they are artisans, not just laborers. Fly ash waste from nearby coal mines is added to cement concrete. Fly ash, being a pozzolanic material, improves the strength and durability of concrete and reduces the risk of cracking. By substituting a part of cement with waste from coal mines, there are reductions in carbon emissions and waste. Improved workability, making concrete easier to pour and shape. For filler slab, the use of lightweight materials reduces the weight of the slab as well as the concrete consumption.
Using climate consultant, the psychometric chart was analyzed to determine the best passive strategies and the natural ventilation methods for achieving optimum air temperature, humidity, and ventilation rates for a comfortable and healthy indoor environment. The wind velocity range, wind wheel, and radiation energy were all assessed, and the prevailing northwest wind was leveraged to the full extent possible. Additionally, the daylight simulation in Revit yielded 100 to 200-foot candles due to the material usage. The double height office creates an illusion of a larger interior space which promotes visual connectivity and social interaction. To conserve water, we installed dual flush toilets, pressure regulators, and sensor-operated taps, reducing our total daily consumption to 1,612 LPCD from 2,252 LPCD. Our water cycle includes two sources, rainwater and underground water tank. The rainwater is harvested for hardscape and softscape purposes, and the overhead water from the ground tank is used for bathing, washing, cooking, and drinking. The DWATS, a local water purification system which involves multiple treatment stages, is used for the purification of water. The treated water is then reused for non-potable purposes such as irrigation, flushing, recharging the declining groundwater level of the area. Our sustainable development goals include affordable and clean energy, industry innovation and infrastructure, sustainable cities and communities, climate action, and life on land. In the final deliverable, we are looking forward to the energy simulation of a building and further reduce the EUI to the targeted values. We aim to completely rely on solar energy for electricity consumption and to reduce avoided carbon as much as possible. Thank you.
Thank you, IIT. That was a very well-made presentation. I'd like to open it up for question and answers. Amy, would you like to go first?
Yeah, so really beautiful. Thank you. I love that you did the water cycle. That's really important, I think. I'm curious about water in your climate zone specifically, and if there are water issues, I'd love to hear more about that. Or maybe in future analysis, you can talk about that. The costs that you have in your info sheet, can you talk a little bit about your estimating process and how you came up with the costs? And then my second question is about the glazing and how much glazing you've used. Have you considered other exterior wall materials? Did you do sort of an evaluation of glazing versus opaque material?
So for the costing part, right now we had an approximate cost for whatever material we are using, which we are using RCC, the CSEB bricks, and the earthwork which we are doing. So these are the estimated cost. So we tend to reduce this cost. Right now it's just a cost that okay, this percent of our total budget is going for the bricks, and it's just the cost for the budget which we got from MPCA. And for the glazing part, we are treating the double glazing facade with a CSAB brick fenestration, which is in front of the double facade. And that fenestration is reducing the harsh sunlight which is coming inside the interior spaces. Thank you.
Awesome. Lisa, did you have a question for the team?
I had the same cost question because on the summary sheet it says $15 a square foot. So that seems impossible to build a building like this for that cost. So I think that's why Amy was sort of flagging that. So again, it's probably maybe just lost in a calculation, whatever. But I just wanted to say really beautiful presentation. Great renderings, great diagrams. I love that you guys have an architecture and engineering team, that you guys presented it all together. I also really like that you did the daylight analysis, thermal comfort analysis, the water analysis as well. So I think you guys are off to a great start. And and the site diagrams. Love the site diagrams as well. So thank you.
Awesome.
We will definitely recheck the costing because I think there is some mistake. We will definitely recheck for the final deliverable.
Great. Anything else the team wants to add? You have a minute or two left, and then we'll move on. All right. Thank you so much, IIT. You did a great job presenting. We now have a short break, and we will reconvene at 10:40 Eastern Time for our next presentation by Lehigh University. Thanks, everyone. All right, we'll be inviting Lehigh University for the AV check in a minute here. But before we get started, a quick note, we'll be doing a group picture, and we would request all our participants who joined us to stay on till the end, and we'd love to capture everyone. But we have another minute, and then I'll invite Lehigh University to start. Okay, we're at time. Can Lehigh University, all the speakers, can they all turn on their video, and we'll do a quick audio check as well, making sure we can hear you all. And if you can share your slides, just to make sure everything looks good.
How's the audio sound?
Yeah, sounds good. We can hear you.
Awesome. Good over here.
Yes, yes.
Good on this end.
Can hear you.
And on this end?
Mm-hmm.
Same here.
Awesome. Did you also want to share your slides so that we can make sure we're able to see them just fine and you're able to advance, etc.?
I'm pulling them up now.
Sounds good. Yep, that looks good.
Sorry.
You all have a minute to go, so we'll start at 10:42 a.m. I'll let you know when it's time to start presenting.
Okay.
All right, we're at time. You can start presenting now.
Okay. Thank you for having us. We are the Lehigh University Design Challenge team, and we're excited to present our project to you today. Our team came together in October of 2022 and quickly networked around Bethlehem to gain a design partner with Quran Development in November. As you can see on the left, our project is an ambitious 166,000 square foot fit out of an abandoned Bethlehem steel building, a site that holds significant culture and historical value in Bethlehem. While the site has been largely deserted since Bethlehem Steel's departure, we see great potential in the Steel General Office building, especially given the success of the brownfield revitalization with blast furnaces, as seen on the top right here. This project presents opportunity to showcase the limitless potential of the site and demonstrate how we can pair good design and with sustainability to benefit the community as a whole. By bringing net zero into the equation, we aim to transform this brownfield into a sustainable functional space that will serve for a model for the future development of this site, our city, and beyond. I'd like to introduce the 2022-2023 Design Challenge team.
Hello, my name is Andy Chung. I'm from the class of 2024, and I am an ideas major.
Hi, I'm Nathan Stryker. I'm from the class of 2026, and I'm an industrial systems engineer major.
I'm Tucker Amy, class of 2023, graphic design and architecture major.
Hi, I'm Christian Kohler-Schmidt from the class of 2024, and I'm a chemical engineering major.
Hi, I'm Trevor Cross. I'm class of 23, a graduate engineering student.
I'm James Fainley, class of 2026, and I'm an industrial systems engineering major.
So our goal is to retrofit this 5.5-story building located in Climate Zone 5A, preserve its historic character, and promote energy efficiency and sustainability. In order to do so, we plan to install 1,000 megawatt hours of on-site solar and a highly efficient HVAC system. In addition, we will be using a user-friendly building automation app to optimize energy use and comfort while using the lifestyle assessment approach to select eco-friendly building materials. I would like to thank our partners, the Stonehouse Group, Sustainable Energy Fund, and Puron Development.
The location of the SGO building is a crucial part of the sustainable community. There are 2 colleges, a high school, and over 200 apartment units within walking distance, which creates a perfect setting for living, learning, working, and playing all in one place. This unique feature of the neighborhood makes it even more desirable for companies to relocate to this area. And by creating a sustainable and functional space at the SGO building, we can further enhance the appeal of this neighborhood and make it an attractive hub for businesses and residents alike.
The population of Bethlehem is growing rapidly, but there are insufficient office spaces for the new influxes of businesses. As you can see in the table, Bethlehem's most notable businesses and attractions consist of about 12,000 employees, 11,000 students, and 10.5 million visitors per year. With a location between New York City and Philadelphia, there's a great incentive for businesses to move to Bethlehem. Additionally, the city has a thriving artistic and cultural scene, which attracts young professionals to the area. And therefore, there's a need for new office spaces that can cater to the specific needs of these groups, such as flexible working arrangements and collaborative workspaces. And Bethlehem is the perfect city for this, since the close proximity of the area supports sustainable lifestyles by reducing the reliance on cars for commuting.
In a post-COVID world, it is clear that employees want more from their office space. With that in mind, our team has designed an office building that offers a beautiful outdoor park and a range of modern amenities, including a gym, basketball court, and rooftop deck. We believe that a well-designed office space can make employees enjoy their time at work, and that's precisely what we aim to achieve.
So as the floors were already in an open layout, we turned our focus towards a key element of collaboration and interaction, rather than the isolation and separation that's associated with traditional office spaces. Our solution was a modular office space design, which provides companies with the freedom to customize their workspaces and easily adjust to changes in their business. As for the engineering solutions that we plan on implementing, we are going to install argon-filled windows, double-paned argon-filled windows to increase insulation within the building. We're also going to employ a variable refrigerant flow system with a dedicated outdoor air system and energy recovery unit to provide more efficient HVAC. We're also going to implement automated LED lights and also maximize the use of currently existing structural and plumbing systems to reduce the carbon footprint caused by working on the building.
We plan to install around 1 gigawatt hours of electricity per year using on-site solar. We really like the aesthetic design of Luma Solar, but we will need to do more research for our parking lot and rooftop solar design. The use of on-site renewable energy generation will reduce the building's carbon footprint and energy costs while promoting a more sustainable environment.
We recently calculated preliminary energy modeling for the design using train trace. The building energy consumption was slightly less than the production from our planned solar system on site. We calculated that our site EUI would be 68 kBTUs per gross square foot, and we plan to continue modeling and tweaking our design to see how much more we can reduce this number. For building controls, we want to integrate the design of a user-friendly alternative to a traditional building automation system. This would engage our users by making them aware of their energy consumption. It would also aim to maximize the user experience in the building while simultaneously minimizing the overall energy consumption of that user.
We plan to implement a biophilic and ergonomic design for this building. By incorporating nature and tailoring the workplace for the employee, we support the cognitive, physical, and psychological well-being of the occupants, as well as reduce stress and improve productivity. In addition, previous studies have shown that employees feel happier knowing that their workplace is sustainable. As such, we will have furniture and lighting designed for comfort, while also minimizing waste and maximizing energy efficiency.
In terms of overall comfort and environmental quality, we improved the acoustics using mostly carpeted floors, recycled acoustic ceiling and wall panels, as well as natural sound barriers through our biophilic design. Lighter wall colors and variable temperature colors in the LED lighting to support the circadian rhythm combine to match human needs and create a productive environment. Overall air and thermal quality are improved through biophilic design, HEPA air purifiers, passive ventilation, and our VRF HVAC system.
Regarding the durability and resilience of the project, the unique glass atrium design will reduce the cost of heating during the colder winter months. The rooftop deck will feature a French drainage system to control bulk moisture, and on land, storm piping will be installed to mitigate stormwater runoff. On the roof of the building, Tyvek roofing membrane will be installed. This is a moisture permeable membrane, material that is made from 100% recycled material. and it will be used to control excess moisture buildup. As for the sustainability and resilient future of this project, because the structural integrity of the steel remains the same, the embodied environmental impact is significantly reduced. Our project does include a partial demolition of a one-story section on the east side of the structure. The outdoor space located on the northern side of the building will feature a plethora of greenery that will help with carbon sequestration and improve air quality from the adjacent roads.
Thank you for listening. Look, going forward, we're planning on increasing models, going over renders, and making better diagrams for our presentation. We're now open for questions if you guys have any.
Thanks, Lehigh University. Yeah, we'd like to open it up for questions. Lisa, would you like to go first? You might be on mute, Lisa.
Oh, sorry, I thought I hit that button. Great presentation, everyone. I love the team approach. I love the integrated background, the theme throughout the presentation. It's such a great opportunity in the community with your university and with the steel. I love that it's adaptive reuse project. That's the biggest impact we can have, is to not build a new building. And it has so much meaning to Bethlehem, Pennsylvania. So I love that as well. I also, the fact that steel has the highest embodied carbon, and you guys are turning that around and making this a low embodied carbon. I don't know if you've heard about the CARE tool. It stands, I had to look up what it stands for, Carbon Avoided Retrofit Estimator. It was released, I don't know, maybe a month or so ago by Architecture 2030 and some folks on the AIA Code Committee for the Environment. But I haven't looked at it myself, but it might be something you want to just look into a little bit more to really show that embodied carbon, and maybe go back in time to talk about the impacts of steel and how you guys are reversing that. I like that you also talked about the user experience. You're creating an app to go with your building automation system and some of that other thermal comfort analysis. So great job.
Thank you.
I agree. I really love the focus on the occupant. I think that's something that we didn't do enough of in the past. I think that you have a lot of components that are included in the well building standard. So you might look to that for some guidance on other innovations that you incorporate in the next iteration. I heard VRF. I also heard HRAM and train trace. And so I think you said that you're going to improve your modeling a little bit, and I would encourage that, especially some of the thermal trade-offs. With a more robust modeling tool, you'll get a better picture of what you might be able to do with that HRAM and what might be happening in terms of comfort and temperature and heating and cooling loads. And then I think you said parking lot, roof, and rooftop solar. Is that correct? And is that included in your cost calculations?
We are currently looking into the costs of the whole system, but by looking at units like Lumos and other ones, we're trying to figure out an effective cost strategy for that. So moving forward, we do more analysis on the cost of the solar array.
So you're doing a cost benefit analysis potentially.
Yes.
That sounds great. And I think if you do a little bit more energy modeling, you'll have a better picture of the benefits as well as the cost associated with some of that load reduction that you're getting through PV, but also other opportunities for heating and cooling load reductions. So
okay.
Yeah, great job. Love it. Great
Thank
ideas. Thank you.
Thank you.
Thanks, Lehigh University. That was very well presented and lots of good content in there. Next up, we have Ball State University, and we'll begin with AV check for them at 10:55. So we have a minute or two to go.
think all of our Ball State team is here.
Great. We'll get started in a minute with your AV check. All right, we're at time. Do all the speakers want to just unmute themselves one by one, and we can make sure your audio sounds okay, and then you can also share your slides so that we can make sure it looks good.
Yes, hello.
Yeah, we can hear you.
Yeah,
Slides look good.
I'm Derek Baum. Can you hear me okay?
Yeah.
Can everyone see the screen there?
Here we go.
Yes.
Can you guys hear me okay?
Yep. All right, we have 2 minutes to go, so we'll be starting at 10:57. I'll let you know when you can start your presentation.
It's messing with my thing.
All right, you're at time. You can start presenting now.
Okay. Hello, everyone. Thank you for your time and attention. My name is Derek Baum, and I'd like to introduce you to the rest of Team New Air. Our site is southeast of downtown Indianapolis in the neighborhood known as Twin Air. Our office building is designed for the triangular lot that you can now see here. To the west, you can see the remnants of the old drive-in theater that the area is named for. To the east, you can see the parking lot and some of the buildings that make up the new Marion County Community Justice Center. This very specific context has helped us design a very specific piece of architecture for this community. One of our first priorities was to inspire hope and bridge the gap that is often present between communities and those individuals coming out of the justice system. Understanding these needs led us to develop 2 different office towers to better address the variety of needs in the area. The northern tower is dedicated primarily to reintegration programming, while the west tower offers more traditional office space. The landscaping around and the ground floor of both buildings provides recreational, retail, and cafe spaces, amenities that the community has expressed a need for. The Great Places 2020 report does a really great job of quantifying these needs and opportunities that are specific to Twin Air. Our design also benefited from the input of key community partners like CDC, Indianapolis Metropolitan Development, and PACE, a nonprofit organization that has been dedicated to reducing recidivism rates in Marion County for more than 60 years. Our cost analysis still needs some attention, but our early estimations show that for our approximate 180,000 gross square feet, our design with current inflation estimates is about $325 per square foot. I also would like to highlight a great resource that influenced our design tremendously was a guest that spoke with us about his personal experience coming out of the criminal justice system and the challenges that he faced. This individual also helped us better understand how that experience informs the kinds of interior spaces he prefers and what to avoid. So as you see here, lots of natural light, great views, openness, and organic materials. Starting with the top 2 floors of the northern tower, you can see the floor plans for our residential program. Double height spaces in the corners and center of the building help unify these two floors. This feature is limited to these areas where it will not be detrimental to the experience of the occupants. This portion of the building provides a total of 36 rooms and 72 beds for participants in the reintegration program. Each room has a small kitchenette and a larger communal kitchen and gathering space are on the lower floor. You can see here on the bottom, 13 represents the kitchen, 14 is the game lounge, and 8 there in the center on that bottom floor plane is the communal lounge. If we skip down to the lowest level, represented in gray in the section on the left, is the Northern Towers administrative programming. A key design feature that I'd like to highlight here is the privacy that is afforded to our counselors and their clients with an STC rating of 58. Delicate and meaningful conversations can take place in confidence. Sandwiched between the residential and administrative spaces are 2 floors dedicated to the educational programming. A variety of classroom sizes and types provide spaces that are tailored to the needs of particular groups and their learning objectives. Again, it is worth highlighting the strategically placed double height spaces that celebrate the transformations that are taking place here. In the West Tower, there's intentionally less variety. These floors are simplified to make dividing them up for law offices and simpler typologies quick and easy. Centralized circulation and stacked restrooms also help keep the construction cost down to a minimum.
Hello, my name is Alejandro Andres Flores. Our open air elevated garden inside is home to many native flora. All trees and plants on site require little to no maintenance as they are found in our regional climate zone. Doubled with a small water collection system, the plants and overall site has readily access available to water. All of our trees on site act as a natural carbon sequester and mitigate our overall embodied carbon. Speaking of embodied carbon and natural carbon sequestering, our team has decided to design the new air project using mass timber. Our team believes that mass timber is the right choice for sustainability, carbon sequestering, and overall versatility. So you might ask yourself, why mass timber? Resilience. Wood is naturally flexible. During high winds or seismic activity, mass timber can withstand large loads while retaining its natural elasticity and strength. Durability. Wood has the ability to absorb and release moisture and is resistant to many chemicals that negatively affect steel and concrete. When designed properly, mass timber requires little to no maintenance or repair costs. Fire safety. Just like wood found in the forest, mass timber chars when exposed to fire. It retains its strength while slowing down its total time of combustion with a layer of char. It's important to know that a single 7-inch thick CLT wall has a fire rating of 3 hours, which is 1 hour longer than code requirement. We'll be using glulam beams and columns partnered with recycled steel fasteners for the majority of our structure. Strong CLT floors and walls will be used along with Portland concrete cement. The New Air team is focused on multiple passive design systems that will enhance our overall building performance. For example, we're looking to utilize our breezeway level as the inlet for a stack effect system, letting warm summer air pass through the curtain walls to avoid overheating in warm months, while using the system to trap hot air to create a hot, warm blanket in the wintertime. This is our selected floor system. We have designed all floors with 7-ply CLT base carrying a raised strong floor system. The raised floor system has many benefits for this office building. All wiring and cables can be ran below the floor and tenants can adapt and customize locations of outlets, cables to their own need. Something isn't working under the floor system? No problem. Simply remove a floor tile and everything can be fixed. New Air uses a closed horizontal geothermal loop system in tandem with the VRF system to heat or cool all air. We also have a rooftop ERV for energy efficient ventilation, creating a healthy, breathable environment. Going further, we would like to investigate the potential to moving that our closed loop system to the west of our site into the old drive-in movie theater to provide ground source energy for more buildings around the area. We have selected a Panasonic HIT high-performance solar array system to harness solar energy on-site. These panels have an efficiency rating of up to 19.7%. We will have a total of 515 panels per building. With the addition of a solar array, we will be able to achieve a net zero score with an overall EUI score of 22.7 before the addition of solar array. Our team has conducted many solar studies and wind calculations to determine solar heat gains on our site. The use of artificial circadian light is used throughout both buildings, and this is very important for office environments. Our office building is equipped with interior daylight sensors throughout the tenant spaces that connect to exterior sensors to provide real-time ambient light conditions to adjust interior lighting to keep workers' circadian rhythms in sync. Our LED lighting system ranges from anywhere from 2,700 Kelvin to 6,500 Kelvin. Furthermore, a floor raise system designed to pressurize the cavity space underneath the flooring to serve as our main HVAC distribution system. This eliminates any ductwork needed. The flooring system comes with a field-applied acoustical pad for impact-resistant sound isolation and vibration control, which is very important for office tenants. This will create an overall quiet office environment. Moving forward, we are still looking to integrate sustainable and recycled materials in our interior and exterior spaces. Thank you very much.
Thank you, Ball State University. That was wonderful. You all brought a lot of energy to the presentation. I'd like to open it up for question and answers. Amy, we can start with you.
Great, thank you. Yeah, great presentation. Love so much the concept of reintegration and addressing those needs in the community. I question a little bit the cost analysis that you've done, and I'd encourage you to dig into that a little bit more, just because of the shape of the building and all of the different systems that you have, which are very innovative and exciting. So did you use means? What were you using for your cost calculations?
Sorry, I had to figure out how to unmute that real quick. We used basically a pretty up-to-date analysis example from a local construction group, and adjusted it a little bit for inflation, but we do realize that we do need to take a much deeper look into it. It was kind of an initial getting all of our numbers on paper and kind of working it out.
Cool. And did you do a structural analysis also?
I can kind of speak on that. We did have some precedents for mass timber and how that structure actually works. I wasn't able, because we had a quick presentation, go into like a lot of the key factors, but there's a lot of mass timber studies that shows that the structure can actually work on tall buildings, high rises, and things like that. There's multiple firms out in California. There's one in Milwaukee that are doing things like this. So that is the extent to our structural analysis.
Cool. Great job. Thanks so much.
Thank you.
I'll turn it over to Lisa.
Yes, great job, everyone. And this slide right on the top, right, design with purpose. I love your program, the reason of being for this building. It's a beautiful one. Great presentation. I think there was a good mix of overview of the project and detailed information as well. So thank you for providing that mix. I would have liked to just have more of a quick introduction on the team to just sort of understand who's doing what and all that. I was able to go back to that slide because it doesn't look like everyone on the team got to speak today. I love that you guys are using mass timber. You did sort of some of that site analysis. I think you have great diagrams. And I like that you acknowledge where you guys still need to do some work. But I think you guys are off to a really good start.
Thank you very much.
Greatly appreciated.
Thanks once again, Ball State University. That was wonderful. Next up, we have University of Illinois, Urbana-Champaign. They'll be presenting at 11:10. We have a few more minutes, so I'll let you know when you can start with the AV check. All right, we're at time. We can start with an AV check if all the presenters want to turn on their video, and we can also go around and do like a quick audio check, making sure we can hear everyone.
Hello, everyone.
We hear you. There was a bit of an echo there.
Is it better?
Yes, this is perfect.
Testing.
Wait, it's cool.
Testing.
Testing, good morning.
Yeah, that was fine. There was no echo there.
Okay, I'm turning on my speaker.
Testing.
That was fine, I think. Yeah.
Good morning, everyone.
Oh, there was an echo there.
Is there almost in room? Testing.
That was fine.
If
If most of you are in the same room, I would recommend only one speaking or
Good morning.
audio device.
I think the audio sounded good. You're at time, so you can go ahead and start presenting.
Can you give us like a few seconds? We were just confirming our.
All right, yeah. Can take a few seconds, and then we'll start your time.
Okay, we're ready to start.
Yeah, you can go ahead and start.
Good morning, everyone. We are the University of Illinois Solar Decathlon team. We chose to design an office building located in downtown Chicago amid a dense urban core overseeing an expressway. The present site is a rented parking lot with surrounding sidewalks lacking pedestrian-friendly areas and retail spaces for community engagement. We have collaborated with Ratio as our design partner, who are also our potential clients for the office building. Our design team of approximately 30 members with 9 sub-team leads have contributed towards the project. Understanding the lack of specific space programs such as gyms, social spaces, and mobile work areas in the nearby vicinity, our design goals were driven to promote collaboration, worker health, optimize energy efficiency, and implement well standards. With a community age of around 32 and a chunk of employed population being millennials, our design narrative attempts to bridge the gap between the residential and commercial district. Our building will serve as a catalyst for pedestrians to get engaged and find a purpose to stimulate their senses. We choose this particular location to resolve issues of heat island effect, sound pollution, promote community development, and improve walkability.
We organize the space based on acoustic properties of the site, keeping in mind the highway along the west of the site. We placed studio spaces closer to the highway and planned quieter spaces towards the east of the site, highlighted in green. The atrium and the circulation of our design function to bring and circulate air throughout the building while allowing people to reach their designated spaces.
In order to address sound pollution coming from the highway, we designed a concrete wall that spans the length of the site from the cafe and bike storage. Within these panels, we're embedding some specks of glass to allow for some transparency in the urban forest and give drivers on the highway a more pleasant view. For the programming on the ground level, we really wanted to activate this space and give back to the community. With the urban forest, we're giving back some of that green space that is typically lacking in the heart of the city. With the amphitheater, we're providing a space for gathering where different events or shows can be hosted. This would be a rentable space that can operate past business hours, as well as the open air market to increase commerce and extend our indoor retail to the backyard.
Here's a sample floor layout of the building. As mentioned before, we organize our spaces by prioritizing acoustics and sound quality. On the northeast end is one of our office spaces, which features an open floor plan layout to allow movement and encourage interaction among employees. We have also incorporated private booth rooms when designers may need to step out and work in a quieter environment, making it flexible to their needs. On the southwest end is a studio space for model making, as well as a break room, spaces that may not need as much protection from the noise of the expressway. Terraces are also located here for access to fresh air.
This is an interior view from the main lobby. We have an atrium that spans throughout all the levels of the office, and in terms of materials, we have hardwood flooring, and we're sticking to our more neutral color scheme to maximize the appearance of natural daylighting for our users.
Our market analysis process included a series of interviews and surveys that obtained a general understanding of the profile of our tenants and what workers today want to see in their offices. From the information we gathered, particularly pertaining to the supremacy of open space, the need for natural sunlight, accessibility, walkable spaces, and a sense of city life, we set out to integrate all of these features as core components of our building. We understand that work life has experienced an irreparable schism pre and post-COVID, and so are adapting to new realities such as a hybrid work while making the office as attractive a space as possible for employees. We estimate the total construction cost of the building to be at around $42.6 million, with the breakdown being as shown. The building's core shell cost shares a higher than typical proportion, but it's offset by savings in energy efficiency. And with our financing sources and projected rental income rates, we are confident of the economic fruitfulness of the venture as we are of its positive social and environmental impact.
One environmental feature is included on the south-facing facade, where we have designed a solar chimney to help regulate temperature while assisting with the ventilation of the main building. From this solar chimney, the surrounding ventilation improves by providing more of a natural regulation through heat convection while decreasing the ventilation energy load by 60%. We also wanted to capitalize on Chicago's windy weather and implemented vertical axis wind turbines on the main building roof and ground area. We chose these turbines because they can capture wind from any direction with their design. For the PV panel design of our building, we included solar panels on the main building roof, cafe roof, and bike garage roof. We also implemented transparent PV panels along the south-facing facade, generating enough energy to have a payback period of 3 years, given our specific location, large total area, and module specifications. To estimate the energy performance, heat energy demand will be the largest percentage from our cold climate zone. In terms of ventilation load, the percentage is comparably low because of our implementation of the solar chimney.
In terms of our material selection, we decided to go with a mass timber superstructure as part of the growing rejuvenation that it has experienced in urban cities. It offers unique advantages with its fast and simple installation, simple fabrication, natural insulation properties, and has a perfect material for carbon sequestration with an incredibly low carbon footprint. Our design provides structural resilience to withstand extreme load conditions, whilst contributing to the environmentally friendly nature of the building.
In order to preserve the unity between the building's passive building strategies and the required ventilation, heating, and cooling loads, the Dakin roof pack and VRV units were utilized for easier zone control throughout the indoor environments. These units can be individually and simultaneously controlled via Dakin's cloud service. Our site utilizes a mixture of efficient electrical and plumbing strategies. LED circadian lighting with local LED panels were utilized for large spaces. The electrical system is controlled by ambient motion sensors in order to reduce unnecessary energy consumption. The plumbing system consists of dedicated water heaters for each floor and a reheat system that gains heat from the building's geothermal pile foundation. A rooftop rainwater collection system also provides additional water needs for outdoor irrigation.
We chose the window U value to provide the most insulation and lowest environmental impact, concluding with a value of 0.36, while also doing the same for the R value, referring to the walls, floor, and ceiling. For the insulation, we chose rigid foam and fiberglass to make the embodied environmental impact as low as possible. To consider our holistic environmental impact, we selected a site with high access to public transportation, offering our target market sustainable transportation methods. Likewise, we took into consideration the highway, which is nearby to the west, and to provide opportunities for carbon sequestration. Timber is a sustainable choice compared to alternatives like concrete, and to minimize waste, we have integrated composting services throughout our site.
Energy biopanels provide the site with additional energy production as well as energy savings via thermal heat gains. Also shown here is a diagram that depicts all of the building's integrated energy performance strategies.
In addition to sustainability, our design is centered on occupant experience, so we followed the WELL building standards when implementing programming such as daycare and a fitness center. The building will also come with an app designed for the comfort of office workers, who will be able to adjust their indoor environment, order ahead from the cafe, access the building securely, and view energy usage statistics. In a hybrid workspace, employees can quickly see who's in and out of the office and send messages. The app will learn control preferences and automatically set to energy-saving modes.
In sum, our aim was to create a mixed-use office building that embodies a very progressive philosophy for a changing world. We center on public space, greenery, and economic opportunity, and our building provides unique benefits for the mental well-being of its tenants and pedestrians. It's also sustainable to the point of near self-sufficiency and provides ample utility. We see this model as an inspiration for the future of urban city creation and hope to inspire similar projects through it. Thank you.
Thank you, UIUC. You all did a great job presenting. That was a well-rounded presentation. Let's open it up for question and answers. Lisa, can we start with you?
Sure. Thank you, everyone. Great presentation. I want to just go back for a minute. I love the urban analysis axon diagram. That was really great. But your other slides, I was kind of not seeing the context of how this sort of fits in. And missing, I think you could have spent a little more time in the beginning just sort of explaining the program. So this is going to be an office for ratio. I'm just, so if you can go back to the site plan, you only have sort of one sample floor plan. So I just maybe in the next stages, a little more information of the different pieces of the building and how that goes together, and maybe more detailed sort of site analysis would be great. I love that you're integrating the well building standard, that you have that occupant experience app. I think that's great as well. And that you started really with some of those design goals. I like that you're connecting it all in the bottom to the 10th contest of the solar decathlon. And I appreciate that you are also using mass timber and thinking about embodied carbon in those ways as well. Amy?
Yeah, I 100% agree with that. I was wondering about the programming as well. So next time, just overall floor plan and maybe a discussion about who your occupants would be, especially since you have such a nice focus on occupants. And I love the idea of a building app as well. It seems from your energy approach, it seems like you threw everything at it, which is great. I think that that's what we need to do. I wonder if you've done enough research into the algae and the wind. I would just dive a bit deeper on those and see how they function. And I was wondering on slide, oh, you don't have numbers. The daylighting slide or the cross section, where did that rendering come from? It's really beautiful. It's at the beginning. Did you do a daylight study?
Yeah.
Also, I'll say good job shaking off.
I'm sorry, is this the
technical
slide that you're referring to?
No, let's see. 1, 2, 3, 4, 9. It's slide 9, I think. Interior view of the lobby. With the finishes, yep.
So for this rendering, we used Lumion software, and this was like from Revit, import into Lumion. And yes, we did daylighting analysis, and this is what we caught for the interior view from the lobby.
Awesome. And your energy modeling, how did you go about doing that, or have you?
So we used Open Studio. We modeled our massing into SketchUp and then exported that into Open Studio based on like our zonings and our distribution of HVAC systems, how we want to go about that.
I think it's a really interesting HVAC design, and with the rooftop units, I feel like it's maybe a backup kind of strategy or like a supplemental strategy, but I would talk a lot more about how you are integrating all of these different thermal supply systems together, because you have the natural ventilation, you have rooftop units, you have passive strategies in addition to natural ventilation. I would also suggest, if you really want to impress people in the next iteration, doing a CFD study. And I think that goes for all the teams that have natural ventilation. that's something that is definitely a hot topic in the industry, and knowing how to do that will be really valuable if you're trying to get jobs. So natural ventilation is really important. It's really hard to design though. So great job. Love the presentation and all the thought that went into this. And
Thank
good
you.
job
One of our
shaking off
members
the
will comment
technical
on
stuff.
that.
It's interesting that you bring up the CFD study because we did do one of those. We set the building in a wind tunnel to help us shape the geometry, as wind is very important. We just don't have the graphics with us today.
Awesome. Thank you so much, UIUC. You all did a great job once again. With that, we wrap up all our presentations for today. I would like to thank all the teams that participated. We really appreciate all your effort, and we on the organizer side always love hearing all these ideas and innovation that comes across. So I want to congratulate everyone that presented today. Do the judges have any final words before we wrap up everything today?
Great work.
No, just-
Thank you all for the
Yep.
effort you've put into it and the time. We really appreciate all of your great ideas and the well, rehearsed and thought out presentations and the great visuals. Thank you so much. I know it's a lot of effort and there's a lot of nerve that goes into it. So we appreciate you.
Yes, everything Amy said, great job, and a lot of work and effort, so thank you.
Thank you so much.
Awesome. Thank you, everyone. Before we all log off, I'd love to get us all on video, and if we can do another group photo, that'll be great. We want to make sure we get everyone who participated today. So I see a lot of participants in there. Yeah, you all look great. Awesome. All right, here goes. Smile, everyone. Awesome. Thank you so much once again for participating. We loved having you, and goodbye.